So today's lesson is on what we call concurrency in triangles. Concurrency, does anybody know what that means? Concurrent. C-O-N, what is that? What does C-O-N mean in Spanish? With current. With current? That doesn't even make any sense. No. Well, concurrent means where two things are intersecting. A point of intersection of two lines is a point of concurrency. Okay? So, what's that? It's not really like congruent. But that's a good connection, but it's actually not really like that. So these are called points of concurrency. Okay? So this is going to be flashcard number 10, and that's what we're going to call it, points of concurrency. These work for all sorts of triangles. And of course, what we'll be doing in a little bit is actually constructing some points of concurrency. But we're going to start by just learning what the points of concurrency are. There are 4 different types of points of concurrency, and the points of concurrency you get when you construct something specific about a triangle. The first point of concurrency is called, so we're going to write this actually. This works for any triangle. Okay, so you guys have been hearing some different types of triangles, right? Right triangles, isosceles, equilateral, scalene, obtuse, acute, any kind of triangle you can think of, you can construct these points of concurrency. Okay, so the first one is called the incenter. And it kind of is going to be right where it sounds like it should be. It's going to be in the center, okay? But, I know, right? But it's actually not necessarily the center of the triangle. It's the center of the inscribed circle. Okay, that will make more sense when we actually construct them. You get the incenter by finding the intersection of the 3 angle bisectors. So we're just going to write down what it is. So this is the intersection of 3 angle bisectors. Okay, the second point of concurrency is called the orthocenter. Like the orthodontist. Not really. And the orthocenter is where you're going to find the point of intersection of the 3 altitudes. So the orthocenter is the intersection of 3 altitudes. And this sounds really ridiculous, but does anybody have an orthodontist that's tall? Because altitude is height. So if you know that your orthodontist is tall, it can remind you that orthocenter goes with altitude. I know you guys are laughing, but this has worked for me for like 4 years. The students are always like, the orthodontist is tall. I'm like, okay, so there you have it, just for you. All right, the third one is called the circumcenter. Circum sounding kind of like circumference, right? And so the circumcenter is the center of the circumscribed circle, which is when you put a circle around the triangle. This is the intersection of the 3 perpendicular bisectors. And hopefully you're remembering that you can construct all of these things, right? Right? Yeah, we can construct angle bisectors, right? We can construct altitudes. We can construct perpendicular bisectors. So if you can construct 1, you're just going to have to construct 3 and find the point where they intersect. The fourth one is called the centroid. And this one is going to require a little bit more discussion on our part because the centroid does something very specific to the segments that you'll construct. So we'll talk about that in 1 second. The centroid is the intersection of the 3 medians. You guys all remember how to construct a median? Because median goes to the... Where do you draw the median to? From a vertex to the... What does median mean? Middle. It's the midpoint of the opposite side, right? So you would construct the 3 medians, okay? Now, the centroid point itself, centroid, divides any of the medians in a ratio of 2 to 1. And I didn't save myself as much room as I wanted, but that's okay, we'll make this work. So draw a triangle over here and draw a median. So let's call that point the centroid. Now you would get the centroid by connecting all 3 medians, but I'm not going to draw all 3 of them on this diagram because I don't want it to get in the way of the concept that I want to talk about. So I want you to label these 3 points A, B, and C. We'll call the vertex A, the centroid itself we'll call B, and the midpoint of the opposite side we'll call C. So this segment is divided into a ratio of 2 to 1. The distance from the vertex to the centroid is twice as long as the distance from the centroid to the midpoint. Okay? So AB is equal to twice BC. Does that make sense to everybody? AB is equal to 2 times BC. Okay, so if we knew the distance of one of them, we could find the distance of the other, knowing the ratio. If we knew the length of the whole thing, we could find the distance of each using the ratio. So we can use all of that. So if AB is twice as long as BC, what is AB compared to the whole entire median? This is twice as long as this. So how much is AB compared to the whole thing? 2/3. Because 2 and 1, the ratio is 2 to 1. 2 and 1 add up to 3. So AB is 2/3 and BC is 1/3. Does that make sense? So AB is equal to 2/3 of AC. And I'm going to squeeze it in down here. BC is equal to 1/3 of AC. All right, so there's your 4 points of concurrency: in-center, orthocenter, circumcenter, and center. Page 42 in the packet, we're going to construct an in-center, and in-center is the intersection of the 3 whats? Angle bisectors. So let's think back about how to construct an angle bisector. I'm going to start with this one, so I'm going to put the tip of the compass on the vertex and do what? Draw an arc. And from each point where the arc hit the 2 sides, I'm going to do what? You're either going to make, remember you could make, I'm going to actually make this a little bit bigger so it's kind of out of the way. You can make the little X out here, or you can do like the whole fishy thing. I think the fishy thing gets a little crazy. But don't change the compass setting in between these 2 arcs out here where you just made the X. So then you get your ruler, or I should say straight edge, because we're not measuring anything with it, right? And we're going to connect the vertex to that point of intersection. And so if we want the in-center, we have to do this how many times? 3 times, right? So I'm going to come over here. Now, most important thing, when you draw that first arc, it has to hit both sides of the angle. So if you, turn in the paper a little bit here. If your compass is open too wide, this isn't going to work for you. And I did suggest last class, if this is really confusing for you, if this is just too many construction marks on one page, you might want to think about getting some colored pencils and changing your pencil out for colored pencils so that you can look at each construction separately. Okay, so one big arc, and then from each end point, I'm going to make an arc out here. Now, once you have 2 angle bisectors, you actually know where the in-center is, but you should definitely construct that 3rd angle bisector to make sure, but where those 2 meet should be the in-center, but you're going to want to construct the 3rd one just to make sure. So one more time, and you can make these again as wide or little as you want. I'm going to make this one little so I can see it pretty easily. And I'm going to put this way out here. So I'm being a little bit strategic about where I'm putting my, oops, I didn't do that long enough. I'm being a little bit strategic about where I'm putting my compass here so that I don't get too confused. There we go, that mark shouldn't be there. But again, colored pencils might come in handy here as well. And hopefully when you draw this one, it will go through the in-center, or at least close to it. Mine's a little bit off, but there it is. And you know, you guys have learned by now that it's really easy to make human errors here when we're constructing things. Your compass can accidentally move a little bit in the middle. You know, the width of the pencil even affects it a little bit, okay? So you're just going to do the best you can. If it's way off, erase it and start over. If it's pretty close like mine was, that's perfectly fine as long as all of your construction marks are on the page. Are we ready to move on to circumcenter? I think I was being a little bit slower than most of you. All right, so circumcenter is the intersection of what? Perpendicular bisectors. So what you're going to do is you're going to treat each side of the triangle, move this up so we can see it. We're going to treat each side of the triangle as a segment that we need to bisect, and this is your fishy thing, right? So the construction marks are going to get in your way a little bit, but this is just 3 bisectors. So the most important thing is that the compass is open more than halfway. So I'm going to do the bottom side first. Remember, we talked about you unfortunately cannot erase construction marks, so if they're in your way, you just have to try to ignore them as best you can. And the perpendicular bisector, you know, the intersection point can actually be on, in, or outside the triangle, so you want to make your perpendicular bisectors pretty long so that you can find that circumcenter pretty easily. So there's the perpendicular bisector of that side. Now I'm going to do this side over here. So again, make sure you're open more than halfway. And I'm just going to try to get it so that I'm not overlapping my constructions too much. And then once you do the second one, you can see where the circumcenter is. So then for the third one, you don't have to make it as long as the other ones. Okay, so I'm going to do my perpendicular bisector here. I'm going to try to make this one a little bit shorter so I can see it pretty easily. Whoops, I just tapped the camera there. And hopefully again, we're going to find that point of concurrency. And in the end, it really does look like a big sloppy mess, doesn't it? You should feel bad for me because I'm the one that has to grade these constructions and make sure all the work is in the right place. Okay, so it looks sloppy, it looks crazy, but our 3 perpendicular bisectors intersected at a point, and that point is our circumcenter. Okay? Now, it's going to be very different when we have an obtuse triangle. So let's look at the next page. Even if you're a little bit behind, move on to page 43 here so that we can take a look at this one together, and then you can go back and fix those up later. Okay? So the circumcenter, again, is our perpendicular bisectors. We're doing the same thing. You're going to have a very wide compass for this first one, right? Or if you do this one first. I guess you don't have to do this one first. And again, we don't know quite where this is going to intersect, so I'm going to make a really long perpendicular bisector. Notice that they gave you a lot of room for this question, so it's very possible you're going to need that room. So I made it really super long. When I do the second one, I'll be able to figure out where that point is. So I'm going to do the next longest one next. Let's see how strategic I can be here. Yeah, this is definitely going to overlap quite a bit. Whoops. And so when you draw this one, do you guys see where the point of intersection ended up? Way down at the bottom. Way, way, way down here. Okay, so it's possible for an obtuse triangle that you're going to end up outside the triangle, so you just need to be aware that that could happen, and then you're not doing anything wrong when you do that. So the third one, I'm just going to kind of keep contained in here a little bit, and hopefully when you draw that line, again, it'll go through that point of intersection. Mine is off a little bit. but not too bad. And that's way down here. So remember, the circumcenter is the center of the circumscribed circle. If I have to draw a circle that has all three of these points on its on the circle, the vertices have to be on the circle. Doesn't it make sense that this circle is going to have to be really huge like this to get all three vertices on there? So that's why for an obtuse triangle, the circumcenter is going to be outside the triangle, because there's no possible way to draw a small circle to hit all three vertices. So it's got to be really big, which makes the circumcenter come way outside. Okay, we're going to skip 2B for a second. I just want to show you how to construct a center of a circle. So let's look at page 44. And we're going to start by writing down a theorem. This is a theorem that you will revisit later this year when we do our unit on circles. But the theorem is, do you guys know what a chord of a circle is? No? Okay. A chord is just a connection of any 2 points on a circle. Okay, so I can draw a line connecting 2 points on the circle. That would be a chord. Okay, so if a chord and a diameter intersect, they will be perpendicular and the diameter bisects the chord and its arcs. So we don't know where the center of the circle is, so we cannot construct the diameter. You need the center to construct the diameter, but can we construct a chord? Yeah, a chord just connects any 2 points on a circle. So pick 2 points, use your ruler to connect them, and you have just constructed a chord. And you only need a straight edge to do that. Okay? Now that chord has to be perpendicular to the diameter, and the diameter has to bisect the chord. So what construction am I going to do? Perpendicular bisector. We're going to bisect this chord. So everybody do that. More than halfway, right? And what you're really drawing when you connect these is the diameter. So make sure it goes all the way through the circle. You can, in fact, just connect the 2 points on the circle and you don't have to go all the way to your X. And there's a diameter of the circle. Can I locate the center of the circle currently? Somewhere on the diameter. Somewhere around here? Here? Oh, see, we don't know exactly where it is. But we can bisect the diameter. Where the 2 diameters intersect will be the center. Okay, so bisect the diameter. Make sure you're open more than halfway. This might be a situation where you don't do the whole fishy thing, but rather just a little mark on top and a little mark on bottom. Oops, except I didn't have enough room to do that. Bad job on that one. And then when you connect your 2 X's again, you're creating a second diameter. Since all diameters have to go through the center, this guy right here has to be the center of the circle. Okay? So draw any chord you want, bisect it to get the diameter, bisect the diameter. The point of intersection is the center. So you would, if you were given a circle and you needed the center, you would have to construct the center before you can do anything with that circle. And that's going to be it for the classwork. Where's that button?